Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for this week's episode. Thank you for joining me on the show today. Per request from a number of listeners, I know you guys enjoy the technical episodes, the case studies. That's what I've got for you today. I'm going to share two vehicles that I dealt with recently doing mobile programming and specifically for these episodes, diagnostic work. The vehicles I have here are a 2017 Ford F150 with some airbag sensor codes, or code, I guess, and then a 2015 Chrysler Town Country that is a crank no start. Both of these were interesting as far as the diagnostic procedure and what we ended up finding. So we're going to jump right into it here. I'm going to start with the F-150. And again, this is a 2017 Ford F-150 regular cab pickup truck. The body shop that I do some work for called me in for this one, and they said it had an airbag light on, had a code for one of the front impact sensors, and they had tried swapping the sensors left and right to see if the code would follow the sensor, and then they were going to replace the sensor. They did that, and it did not change. The code stayed on the left side, and the code that we had, and I scanned and I confirmed this, was a B1413, and I think a 1417 would be the opposite side, but this is for the driver's side front impact sensor or crash sensor for the airbag system. So my goal is to figure out exactly what's going on. Do we have a circuit issue? Do we have a module issue? Is there something with the sensors still, even though they swapped them over? You never know. Maybe it's like a left-right type of situation where they only belong on one side. Of course, if that was the case, I'd expect there to be codes on both sides once swapped. But either way, I want to verify. A lot of times shops will tell me, yeah, we did this, we checked that. I still have to see it for myself or confirm it for myself in a lot of cases, because I've been in situations where, I've been given some information and I've skipped over that portion of the test because I'm just taking them at their word. And not to say that maybe they didn't do it, but, in some cases, maybe the tests that they said they did, they didn't interpret it correctly, or something was missed, right? I miss stuff all the time too. When you get a second set of eyes in there, it's best just to start fresh and cover everything like you would normally, right? Just follow your process. And so I'm not completely eliminating a sensor as the possibility for this code, but we'll get into the testing and figure out what's going on. So first thing that I wanted to do, and that I always try to do with something I'm not extremely familiar with, is look up the details on the trouble code. And I think this is especially true in airbag systems because these systems are scrutinized by the control modules electrically far more than some of the other systems on the car, right? Now, this is a sensor. This isn't the actual deployment loop. But when we're talking about the deployment loops, whether that be a pre-tensioner or an actual, inflator module, these circuits are looked at very, very closely by the module to say, is it intact? Do we have the correct resistance? Are there any shorts to voltage, shorts to ground, opens, right? And we can set all those different codes for a single circuit because of the methods behind there. And I've had some episodes in the past where I go into depth on the circuit monitoring used for some of the deployment loops. But a similar analysis of the circuit is done for the impact sensors themselves, right? This is one of those systems, or maybe it is the system on the car, where the computer has to assess the capability of the system, both the inputs and the outputs, right? The sensors and the deployment loops. It has to assess its ability to function without actually running any type of active test, right? If we have a EGR valve, for instance, and the computer wants to verify that the EGR system or valve is working properly, we can do some passive circuit monitoring to make sure that it's plugged in. But if it wants to know if the valve and system's working, it's going to monitor it while it's being used, right? There's some sort of monitor that is in the programming of the computer that's going to monitor certain sensor values under certain conditions when the computer is activating the valve. And, various methods of accomplishing that and getting to that goal. But that's what the computer is going to do, is assess it while it's functioning. We can't do that with airbags, right? When the airbags go off, that's not the time to test to see if they're working properly. So what I'm getting at here is the computer, or I should say the engineers who built the computer, but then once it's installed, the computer is using some very specific methods to assess whether everything is functional and ready to go if we need it. Because that's the thing about airbags. They've got to work when you need them to work. And hopefully you don't, but in the event that you do, you want to know that everything works, right? So then we have these trouble codes that are going to indicate any potential fault within the system so that you're alerted before the point where you're in a accident or a crash or an impact and the bags need to go off, but the system's not functioning properly. Okay. And again, I have a previous episode. I'll put a link in the show notes if you want to listen to some of the details on the deployment loop analysis. But this is going to be more on the impact sensor. Now, back to what I started with here is I want to know what the code means. And the reason being is, again, there's a lot of different codes that these airbag systems can set just for a single sensor or a single circuit, because it's looking for things like short to voltage, short to ground, open, and it can have different codes for each potential electrical fault, which gives me, the technician that's doing some testing, a pretty good idea as the direction that I need to head and specifically what I'm looking for. So this B1413, I'm going to punch this into my service information, and I actually had some trouble finding it. So I wanted to share this with you because of that, because I had to do some digging just to get the details I wanted on this code. Now, I'll hand it to my scan tool. I was using the top-down at this point. For this one, you could have used I would imagine a Ford IDS or an Autel probably give you the same information, but the scan tool itself gave me some details on this code that was helpful. The scan tool said frontal restraints sensor, right? The impact sensor driver, which is the side, lack of operation. Okay. So that would point me to believe that there's a sensor fault, but I would like to know some more details. Like, what is the computer looking at to determine it's a lack of operation? What do I need to test as a technician to verify it's a sensor or it's a circuit or it's a module? But I couldn't find this code. So I punched this into Identifix, and Identifix is usually my kind of like first go-to. I like the way they arrange the information. There is a lot of information, not on everything, of course, and this is one of those examples. And of course, they have the archive of fixes, which can definitely help you out. But they didn't have anything on this code as far as service information details. Just said, no documents found when you punch this code in. And so the other service information aftermarket that I use, and of course, Ford would be my last resort if I couldn't find anything, because I don't pay for a yearly Ford service information subscription. Haven't found the need to spend that money yet, but you can buy a short term, and that would be my last result. But I went to AllData because I also use AllData, and I like the way AllData has their information laid out. And so I put this into the search bar in AllData as well. And again, nothing on this code. And I made sure, okay, did I get this code right? Did I write it down correctly? And I look at the scan tool and it's correct. So this B1413 just doesn't show up. Now, this is where, and I always told my students this when I was teaching at the college, you can use that search bar within service information, and I definitely think that you should use it because it makes life simple. It'll pull up the documents you need. But it is good to be able to find what you're looking for within the service information that you're using by navigating it yourself, right? And knowing exactly how to get to that point without the search bar. Because the search bar is kind of going to bypass a lot of clicks for you. You're not going to have to enter the system and then enter description operation and then scroll down. It's just going to pop it up for you. It's quick, it's easy, I like it, but what if it doesn't work, like in this case? And you can try this if you want. Go to Identifix, go to All Data, type in a B1413, and nothing comes up in the search bar. But in All Data, what I was able to do, when you go to the main vehicle page and it lists all the systems on the middle of the screen, one of those is restraints and safety systems. Okay, that's your airbag systems. Once you're in there, on the right side of the screen, you'll see a tab that says testing inspection. So you're going to click on that, and there will be a tab that says initial inspection and diagnostic overview. So you click on that, and I'm giving you step-by-step here in case you need the access codes, for one of these airbag systems on a Ford. And who knows, maybe they fix this at some point or another, but it's a 17. It's 6 years old at this point. So you might run into one of these and need to know how to get there. All right. After that, it's going to pull up a tab that says Access Guided Routine RCM. So RCM is Ford's name for airbag control module. It's restraints control module. And when you click on this link, it will bring you to a page where you can click on DTC index. So it's bringing you to another point in service information where you see at the very top, it says DTC index. And then you go in there and you have the airbag codes. Now, this is different than if you're on the main page and you click DTC or DTC index. I tried that. You can't access the airbag codes, or at least not this airbag code, using that method. I tried that search and that didn't work. I also tried doing this through Identifix to see, hey, could I find the same thing in Identifix? And it does bring you to the point where it says click here to access guided routine RCM, but there's no link. There's nothing to click on within Identifix. So it brings you up to that point, but you can't go any further. All Data did work. And so I was able to get into this and have the DTC index. So once again, real quick, for anybody wondering, it's All Data, restraints and safety systems, testing inspection, initial inspection, diagnostic overview, and then click here to access guided routine RCM. And then you have your DTC index. Once I clicked on that, scroll down or Control F, found my code, and it has some information there. There's actually a pinpoint test procedure, which is really what you get from Ford diagnostic trouble codes. Is it'll give you a description of the code, which this was very similar to what I saw on the scan tool. Left front sensor, lack of operation. But it'll give you a pinpoint test, which has you go through. It's basically just a flow chart, but it's something, right? It gives me details. Now, there was one more thing here. When I typed in the B1413 for this sensor, and I found it in this DTC index, there was a list of subcodes. All right. And we're seeing this more and more often on vehicles, Ford's definitely being one of them, where you'll have the traditional OBD2 format, right? So B for body, and then 1413, which indicates something within that airbag system. But and after that, there's a colon or a dash, and there's a 2-digit subcode in addition to the main code. And I encourage everybody to really pay attention to these because I've found a lot of the time that this is critical to understanding exactly what the computer is upset about, is this subcode. So pay attention to it, not only that it's there, but then reference it in service information. Because within this DTC index and this specific DTC, there was different pinpoint tests depending on the subcode. And looking at some of these, one of them was a short to ground. One of them was a open or short to voltage. One was a lack of operation. And my subcode was 93. That's the one I had set with the main code, but it gave me a specific pinpoint test to click on and then to go through. So scrolling through the pinpoint test for my specific code, which was lack operation of the sensor, I scrolled through, and really the flowchart wasn't fantastic. It's very typical of what you'd see in flowcharts, which is ohm check this wire from here to here, ohm check this wire to ground, ohm check this wire to wherever, right? That's traditionally what a lot of flowcharts have you do. And that's definitely not first on my list for most circuit analysis. Occasionally I'll pull out the ohm meter, it has its place, but ohm checking from up near the radiator to the airbag restraints module, which it has you doing, is just not going to be my first step. Now, I do want to make a note here on step 9. I think this is pinpoint W, was their test procedure. I do want to make a note that step 9 was something I think would have been useful. Now, to be 100% transparent, I didn't read step 9 in the moment when I was at the car. I glanced through this flowchart. I saw a bunch of ohm checks. I saw the circuits it was referring to, and I didn't do any of it. I just wanted to know, okay, what is this? What does Ford want me to do? And sometimes just by understanding what Ford wants you to test, you can get an idea of what's going on. But taking notes for this podcast episode, I did actually read through all of it. So step 9, so you've already ohm checked a few wires by this point, but step 9, which should really be the first step in my opinion, or one of the first steps, it has you at the sensor, unplug the sensor in question, and jump across the two terminals. Okay. Now, for reference here, we have 2 wires going to the sensor. One is a feed, which is a voltage, and then the other one is a ground. And they both go back to the airbag restraints module. Now, the voltage that should be there, although they don't list it out in the trouble code, is approximately 7 volts. And then on the other side, it's a ground that should light a test light. Okay, so if you power up a test light and you touch it, it should light up on the airbag sensor. Now, what it has you do in this flowchart, step 9, is jump these two together, cycle the ignition, and you should see a code change, right? And that all depends on that subcode, right? It's the subcode that changed. And it should go, if the circuit's intact, it should go from a 93 to an 11. And the 11 indicates a short to ground, as opposed to 93 just indicating a lack of operation. And what that's doing is verifying that your ground is good all the way to the sensor, and that the circuit is intact all the way back to the PCM, or I'm sorry, not the PCM, the RCM. Because if the RCM is able to interpret a short to ground by you doing it out at the sensor, the only way it can do that is if the circuit's intact. Right. And so they're saying at that point to replace the module because the circuit's good. And that would be if the sensor was deemed okay in some of the earlier steps. Anyways, the reason I bring that up is that step is actually pretty useful. And I should have paid a little bit more attention to the flowchart because I didn't do that test when I was there, when I was looking at this car. I didn't think of that and I didn't read it. I glanced past it. But it would have been helpful. So I'm bringing it up here just to remind everybody, sometimes the flowchart stuff is definitely useful. Read through it and see what they have to say, and then you can make your own decision on which tests you want to do. Okay. So anyways, basically what this code is indicating to me is that the module's not seeing what it wants from this sensor. Now, what should it see? What does it want to see? The information in the code description, it doesn't make that very clear. It really just has you testing circuits and tells you what circuits and what's involved and that there's some sort of information being transferred. But I'm going to pull on my previous experience here with airbag systems to know what I'm looking for. Now, they call them sensors, the impact sensors, and they are, but I'd argue almost that it's its own little module. And this voltage feed which is around 7 volts, and we see that with multiple brands. I've seen this across the board where it's very common voltage to have 7 volts go out on the feed, have a ground on the other side, and there's an actual little circuit board in these impact sensors in modern vehicles. You go way back and they were actually physical contact points that would open and close. And there may have even been a circuit board in those, but nowadays they're much smaller in size and they have accelerometers built into them, very similar to what is in your cell phone. When you move your phone and, it rotates on the screen and stuff like that. The same thing is it's detecting movement, detecting acceleration or deceleration, and that's how the sensor is interpreting, okay, this vehicle was in a collision or we hit something. It's going to send that information, but it's got a board on there to monitor that accelerometer and to make a decision and send a message back to the RCM. Now, that's only if you're in a crash. What about the rest of the time? Well, there's going to be other messages that are sent from that impact sensor to the airbag module when nothing's happening, but the module is online, right? We've powered up the module. We've sent the 7 volts to the module. The module's on. It's going to send basically a state of health message saying, yep, we're all good. I'm installed. I'm correct for the vehicle. Nothing's wrong. Or it might send something like, I have an internal fault. And like I mentioned, with the circuit codes, that it has a lot of different possibilities to set. In a lot of vehicles, we see various codes that can set for an impact sensor, like, internal fault to the sensor, obviously an open circuit. I've seen on Volkswagens, like, incorrect sensor installed, or like wrong part, or something along those lines, if the wrong type of sensor was used. So there's a number of different messages depending on the application that it can send. How is it sending these messages? That definitely depends on the vehicle construction, but it's going to be some sort of voltage or current fluctuation on that feed line, the line that's supplying the voltage to the sensor, right? So we got a ground, and that's just a ground. But the other wire, voltage supplied from the module to the sensor, that's going to be fluctuated either with a voltage pulse, or we see in GMs, it's a current pulse. I think the same thing's true in Nissans, where it's more of like a current pulse to send messages as opposed to a voltage pulse. And again, depending on the manufacturer and how they want to do it, either way, you can view this with a scope. Even if it's a current fluctuation, you can see with a good scope the messages. Now, you don't know what they mean, but you can see if they're there. You can see if something's happening. And a lot of times what you'll see is if a sensor is dead or not functioning, you'll see the 7 volts come up on the feed line and the sensor won't respond. It won't send its pulse message, right? And so then the module, the control module, will reset that voltage 3-4 times, see if a message happens. If it doesn't, it will drop off to nothing, and then it will set a code. But really what it's doing is it's trying to wake up, trying to activate that impact sensor and get a message back. Hey, you there? Are you working? And if it's there, it's going to hold that voltage, and you'll see those pulses maintain, but you'll see them stay there. That's pretty typical strategy. Now, on this particular vehicle, this Ford, it was a voltage pulse, like a square wave, and the module would send out approximately 7 volts, and you would see a pulse upwards in voltage. And I'm assuming this is the sensor responding, sending messages, kind of like a network signal, right? It doesn't look exactly like a CAN bus, but that's the same idea. And that's kind of why, this sensor is almost its own little module, sending messages, it's communicating. Now, I don't know that there's necessarily back and forth communication with the two modules. I believe this is just a one-way in most cases, meaning that the impact sensor is sending info to the airbag control module, not the other way around. The module is just supplying the voltage for the circuit, allowing that sensor to operate. So anyways, time for me to do some testing with this thing to see what's going on. Now I have a little bit of an understanding of the system. So I go to my left front sensor, I unplug it. I do have a ground light's a test light right there, powered up test light. Okay, so I can assume my ground to the sensor is good. How about the voltage feed? Now, when I tested this voltage with the sensor plugged in, so I was back probed at the sensor, I had about 1 volt on this wire. And I could see a little bit of fluctuation on the line, but it appeared to be about 1 volt, somewhere in that neighborhood on the feed side of this circuit. Now, right in the moment when I was looking at it, I didn't know what the correct voltage level was. I know I just mentioned 7. That's after the fact. After testing this, I know that it's supposed to be about 7. But it did seem low from what I've seen in the past. And one of the good things about an impact sensor like this is you do have one on the other side. And in this case, one that's not coding, it doesn't have a code. So I can just scoot over the other side, the right side of the vehicle, the other side of the radiator, and I can back probe that one. And I can see what does a normal one look like. And that's where I saw, okay, this is normal communication on this wire, is the 7 volts coming from the module and pulse upwards from the sensor communicating or sending data. Okay, so that's what it should look like. It doesn't look like that on the other side. So my issue potentially is something to do with this feed circuit going to the sensor. So now I need to determine, and again, I don't want to rule out a sensor completely, but I need to determine, is it the sensor, is it the circuit, or is there something going on with the control module? So how am I going to do this? Well, like I mentioned before, I just need to rule out the sensors immediately, just so that it is not in the back of my mind because it definitely could be a sensor. And so what I did here was I just quick jumped the wiring from one side to another, right? So really all I did is use my AES Wave, the U-Test terminal, and I connected to the plug that's on the left side, and I brought it over and I connected it to the right side sensor. And it took a little bit of work, not that much, but really all I'm doing there is I didn't want to unbolt sensors. I could have done that, but I didn't want to mess with that. And here's another thing. If you're testing sensors or airbag modules, make sure you're not unbolting things while it's live. That's always a bad idea. You can set off airbags. So I'd rather do this where I'm leaving the sensors intact where they're at, and I'm just kind of scooting the wiring over to the other side, plugging it in. And the shop said they swapped it, and I believe they did. And I was wondering at the moment, is it possible there's like a right-left type of thing? I did end up looking up on RepairLink shop. They're the same part number, left to right on this vehicle. So that wasn't it. And with the right side sensor plugged into the left side circuit, I still had the same code. Okay, so I can eliminate the sensors. I'm not worried about them right now. I can leave those alone and just really focus in on this left side for the moment and to see what's going on. So now I'm going to look at a diagram and see what makes sense to test next, or where's the best next place to test to eliminate the circuit as a possibility. I know I could go to the module. I don't know exactly where it is, but I can imagine it's under the carpet or under the middle of the vehicle, sometimes tough to get to. Is there another place I can go to next? And looking at the diagram, there's a C210, which is going to be behind the glove box on the passenger side inside of the vehicle. And it will actually have all 4 sensor wires for the front impact sensors, right and left, going through it. Okay, so it's going to come up into the cab, go to this connector, and then go to the restraint control module, which I'll probably eventually get to, but this is the next easiest place to test, right? And I'm thinking in my head, just logically, if there is a circuit issue, likely it would be somewhere under the hood of this vehicle as opposed to the inside. Now, of course, that's just going off of what's most likely. I definitely want to do testing to confirm that, but I'm going to check at this point and it'll at least move me either closer to my module or to go back under the hood. And I just want to see what is the voltage at this point. So I go to C210, I test it there. It's exactly the same, right? And I got about 1 volt on this circuit. Instead of the 7 that I have on the other side. And this is actually probably where I would start my testing next time, because you can just move your probe over one spot on this connector and test the right side and the left side. So it makes it very simple to give yourself a good assessment of where to go in this circuit. Do I got to go towards the sensors? Do I got to go towards the module? Now in this case, I got to go closer towards the module. So a little bit of work, had the shop pull up the seat so that I could get to the airbag module, which is in the middle of the vehicle, and do some testing there. Again, if you're working with an airbag control module, do not unbolt it while it's plugged into the vehicle, and then move it around. It has basically a rollover style sensor built into it. And if you move that, it thinks the vehicle's rolling over and it'll set off the current airbags. There's videos out there, people doing that. I know people have done that. So be careful there. You're going to leave everything bolted in if you're going to test these things while the circuit's live, which is the case right now. So I test here my feed wire out to my sensor. Same thing. Got about 1 volt coming out of it. Okay, check the connector. I don't see any issues there. So I'm not so concerned with my circuit at this point because coming out of the module, it's supposed to be feeding 7. It's not. I did try something here. I jumped my left side feed circuit over to the right side, or I should say I jumped the two together, right? So my right side has the correct amount of voltage coming out of it. My left side doesn't. I want to see, because the sensors are the same, I want to see, what if I jump my right side over? And I unplugged the left front sensor at this point, and I jumped over to the other side just to see, does that make the code go away? Does that satisfy the computer? In this case, it did not. I still had my code for the left front, the same one that I had. But this does do one other thing for me by doing this test, because the left front was the only code that I had set. Even when I jumped my right front circuit, was functioning over to it. I have had in the past where that feed to the sensor had been shorted out to another circuit, in particular to the ground side going to that sensor. They were pinched together in a door, and I missed that. I made a bad call on the module because everything looked okay. There just didn't seem to be the voltage that I wanted on the feed circuit, and so I called a module. Well, it ended up it was being pulled to ground by the ground side wire because they were touching, right? And I didn't make that check at that point. So what I'm doing here is I'm introducing the right side circuit, the feed circuit, I'm sharing that with the left side. And again, I unplugged the sensor, but if there's an issue with that circuit, right, that's causing that voltage to get pulled down some way, shape, or form, then it should do the same thing to the right side, right? If it's a short to ground some way or another on that circuit, it should do the same thing to the right side, or at least that's my thought process behind that test. And because I didn't get a right side sensor code at that point, I still only had my left side, and the voltage looks correct on that right side and actually looked correct on the left side as well. I mean, it's all one circuit at that point. Again, besides checking powers and grounds to the module, which I did, I'm pretty confident in calling the module here. So that's what I did, told them to get a module, and they replaced it, fixed the problem, program the module, but good to go. So easy enough. That's that one, control module. So if you see that on one of those Ford F150s, you can be a little bit more prepared to check those circuits and make a call. All right, 2015 Chrysler Town Country is our next vehicle. This was a crank no start. It has the 3.6 liter engine. Many of us are very familiar with these engines because they're popular and they have a lot of problems. This thing cranks over, smells like fuel. Shop even mentioned that. You can smell fuel, so it seems like it's getting some. They said it has no spark, and they said there's no codes, or at least no codes that indicate anything. And they said they put spark plugs in it, but it hadn't gone much further than that as far as replacement of components. They wanted me to check this thing out because they didn't have a whole lot of direction on it. So I hook up to this thing, scan it for codes, and they were right. There's no codes in there. I think there was a couple codes, but there wasn't codes pertaining to anything as far as preventing the vehicle from starting. And it did smell like fuel if you crank this thing over. Not overpowering, but you could smell fuel. Like, okay, this thing must be, injecting some fuel into the engine. but no codes. I looked at my data stream while I was cranking over the engine. One of the curious things I saw was that there was no RPM on the scan tool. And I checked on the factory Chrysler side. I also checked on the OBD2 side, which with aftermarket tools, it's usually pretty easy to bounce from one to another. If you go into the factory side of the tool on Chrysler, it'll give you an OBD2 option within that menu. So you don't have to fully back out of the tool if you want to go to the global side. And the reason I do this is I just want to make sure it's not some weird scan tool glitch, or it's not something where I'm getting, I've never seen this with RPM, but a substituted value of some sort. I like to just go to global if something's not there. And I don't want to jump on a missing piece of data if it's not legitimate. But I saw it on both sides, is my point, is that there was no RPM while I was cranking. Okay. I'm thinking, okay, well, this, might be a simple one. Not sure why it's not setting a crankshaft sensor code. I think these things should, if it's not getting an input from the crank sensor, but I definitely don't see any RPM. I took a look at the cam crank sync while I was cranking as well, and that said out of sync, except for every once in a while it would jump to in sync, which I thought was interesting. So what I did quickly here was I definitely want to look at the crank sensor here because not seeing an RPM is very suspicious, but I did want to verify what they told me, that there was no spark. And so as I'm getting out my scope, one of the first things I did, I just want to see, okay, am I getting spark or not? And what it was, I was getting spark very randomly. I'd get like one spark every once in a while this thing was cranking, but it definitely wasn't anything consistent to get it to start. And it wasn't a situation like a Nissan I'm thinking of, where the timing's off, you get one spark event as soon as you crank it and then no more. Because that was one of my thoughts. Well, maybe the timing's off on this thing, preventing spark. And I questioned myself on that because I was like, I don't think that's the case on these. I've seen these things fairly out of time and they'll still start and run, maybe not great, so they'll set codes, but I haven't seen the Chrysler use that strategy on this engine anyways, where if the timing's out, it won't start the engine or give you one spark, but I would get a spark every once in a while. Okay. Well, again, all this is pointing me towards I need to look at my crank sensor. And the reason I did the spark before the crank sensor is actually getting connected to the crank sensor in one way or another. It's kind of a pain on this one. The PCM is buried in the corner on the left front of the vehicle. The crank sensor is on the back side of the block. So getting tapped into that circuit is actually kind of difficult, but okay, that's where I need to go. So that's what I'm going to do, lift the vehicle up and get connected to my crank signal. And I figure at the same time, let's look at the cams, right? I got my Pico out for this anyways. So let's look at the camshaft sensors and see what's going on. So I do this, I hook up to my crank sensor and I'm just using my U-scope at this point. I crank this thing over and I see what looks like a pretty good crank signal. 0 to 5 square wave. I've got a missing tooth in there, what looks like a missing tooth, and very, very consistent. And this is all the way to the PCM. So it's not what I was expecting to see. Again, because there's no RPM on the scan tool. And it's kind of acting like it's not getting a crank signal. And again, right at the PCM getting there, as there's always possibility there might be a pin fitment issue on the PCM or something like that. But again, it looked like a really good signal to this point. So I'm kind of weighing the options in my head here. Do I take this connector off and check for a pin fitment issue? I'll be honest, I don't see a ton of pin fitment issues on these Chrysler connectors, but if you've done anything with these GPEC style PCMs on these Dodge Caravans and Chrysler Town Countries, they have two big connectors going into the side of the module, and they have slides in them. There's one set with a blue set of slides, and then the other connector has a green set of slides. And these levers that move these slides will bust all the time. And that's actually one of the diagnostics I get called for a lot, is going to look at one of these vehicles that won't start or won't communicate, and they've latched the lever down, but the slides didn't move. So you go up there with a screwdriver and you push these slides into place, and then boom, you're good to go. So my point of this is I try to avoid messing with those connectors unless I absolutely have to. And so I want to kind of make that my last check, right? If I need to, I will, but I want to make a couple more checks, or at least I decided, maybe this is just laziness. I decided I'm going to make a couple other checks before I go to that point, right? I do have a crank signal that's reaching, pretty close to the PCM. But the other thing that I want to check before I go any further is the cam signals, because I haven't done that yet. And again, that's in the back of my head that, well, maybe this thing's out of time. I should note that cranking it didn't sound terrible as far as the compression went, but I do want to check the timing and see where it's at, or just the signals in general. Maybe something with the cam signals is screwing up the computer. I don't know. Let's just see what those look like before I start taking this thing all the way apart. So I do that. I did have to get my Pico out here. I figured if nothing else, at least I can assess that crank signal a little closer, right? The U-scope's great, but sometimes you can miss some detail with it because the screen's small. But get my Pico out, get 2 of the cam signals. I just picked bank 2 because they're easy to get to. There's one connector for the 2 sensors that's all built into one sensor, I guess. Anyways, intake and exhaust cam on bank 2, which is the front bank, and I've got my crank signal up, crank this thing over and take a look. And I can pull a known good at this point to compare it to make sure that the vehicle's in time, or at least bank 2 is in time, right? And then I could do the same thing to bank 1. So I looked at the waveform here and compared it to a couple different known goods. I found one of the same year, 2015, on one of the websites, and then I also found a 2014. Just wanted to pull a couple different ones to see, does mine look the same as 2 different known goods? And if it does, okay, I'm in good shape as far as the timing goes. Now, I did compare the 2 camshafts to each other. They looked perfectly in sync with each other, right? So the intake and exhaust on bank 2 looked good in reference to each other compared to my known goods. Now, in reference to the crank, they were off. I would say maybe 10, 15 degrees or so. They were off in reference to my crank. So at this point, I'm like, well, this thing is out of time. Now, is that preventing it from starting? And that's my question before I call this one. Definitely out of time in comparison to both my known goods, but is that going to prevent it from not having spark? And I really question myself here because I'm like, I know that I've seen these 3.6s start and run when they're out of time, pretty significantly too. I've seen it where the tone wheel will actually slip on these 3.6s, and the timing or the perceived timing for one of these camshafts is wildly off, like by 100+ degrees. And the engine actually runs pretty good. And it's one way you know that the tone wheel is jumped and it's not the actual engine out of time. But again, if that happens, those engines start. And so I was just thinking, like, this wouldn't prevent a no spark situation. And especially because it's only about 10 degrees or so. So again, I just have this question. I don't want to tell them, hey, dive in, to take the timing cover off and all this stuff, and then they get all back together and it still doesn't start. I want to avoid that situation. So I'm thinking about this a little bit more. And it just happened to catch my eye while I was looking at the diagram, or while I was looking at the waveforms, right? So I got my crank and I got my 2 cams, and then I have my known good with the same thing. My crankshaft signal, it is a 0 to 5 square wave. It looked different than my 2 known goods. Okay, so I got 2 known goods, and again, 0 to 5 on those. But something caught my eye as I was bouncing back and forth comparing timing. The missing tooth for the waveform, right? So you, in a normal modern crankshaft tone wheel, you're going to have 58 teeth or 58 notches, and then you'll have basically the space of 2 missing. So a lot of people would say 58 plus 2. So you'd have, if every tooth was occupied, you'd have 60 teeth and about 6 degrees of rotation per tooth, giving the computer a really accurate measure of where the crankshaft is in rotation, right? And we have a missing tooth or a missing gap that is going to indicate to the computer that, okay, this is your sync point. This is where you start counting. This is your spot to start, and then you can start counting. You know exactly where that crankshaft is. It'll compare it to the camshaft, so on and so forth. But you need that missing tooth, right? Well, mine look different than both of the known goods. And without showing you the waveform, I'll describe it the best way I can. The voltage is either going to be 0 or it's going to be 5 on these sensors. That's how they work. They're digital on-off Hall effect switch sensor, which is essentially a switch going 0 to 5. The missing tooth section on my known goods both goes low, goes to 0, goes to nothing. On mine, it goes high. It goes to 5 volts. Where that gap's there, it seems to be, in the right orientation with the rest of the teeth on the crankshaft, but it goes high instead of going low. And I actually pulled another known good, a third one, just to verify that this wasn't normal for this engine. And everything that I could find on these 3 6s, the missing notch, the missing tooth, the voltage should drop down. And mine goes up. Mine, or you could say it stays high, essentially, which definitely is an issue for the computer. And again, that's because that missing gap, that space where there is no teeth, essentially, that's where the computer starts counting to say, okay, let's go, the crank is, and here's the thing, the missing gap doesn't always indicate top dead center, but just for ease of explanation, let's say that missing tooth is top dead center for number 1. Okay, now we can start counting from here. The computer knows exactly where it is. But if it doesn't get that indication, right, all it can see is changing voltages on this signal wire from the sensor. If it doesn't get that indication of a starting point, it really can't ever start counting. And now this is making sense why I don't see any RPM on my scan tool. And I made sure I had all my connections set up right with my scope and everything like that. And everything appeared to be right, but this is definitely an issue here. Now, the only other time that I could recall seeing this is when someone had installed the wrong engine in a vehicle. It was actually a Chrysler, and it was a 2.4, and they grabbed the wrong year engine, and they changed the tone wheel structure. So some of these, they're actually missing teeth. It's just an open space. And then some of these, the quote missing tooth is just one big thick tooth, and that's actually how it's set up on this particular 3.6 engine. So it's not really a missing tooth, it's a big long tooth, and this is a pull down sensor. And so the way it's supposed to work is it's supposed to pull down for that gap, or in this case the long tooth, to indicate the computer where it's at. But either way, they said an engine hadn't been installed on this. So I showed the shop, okay, here's what you're dealing with. Your engine does appear to be out of time. So that's number 1. But there's something going on with this crank sensor. So I told them, you need to remove this crank sensor. And I would just, inspect the tone wheel with a borescope if you can. And they said they did. They had a borescope. It doesn't appear to be any damage to this thing. I mean, it's off of the actual crankshaft, like in the crankcase on this one. And so I've seen where a rod would get thrown in one of these 3 6s and mess up the teeth on this. It didn't appear to be the case because all the teeth were there. It just was almost like it was inverted, right? The waveform was literally flipped upside down from what it was supposed to be. And I've seen a Nissan where that happened, where the sensor inverted, and it was putting out the correct type of signal, but it was upside down from where it was supposed to be. And we replaced the sensor and it's fine. And so I told him, pull the sensor out, inspect the tone wheel. If everything appears to be okay, put a new sensor in it and see what happens. You probably still have some timing issues, but let's just, in case they want to fix this thing, you'll need to address this one way or another. So they said, okay. So I headed out on that one, collect my payment, headed out. And they called me up later. They said, we pulled the sensor out. The tone wheel looked okay, but the end of the sensor had a ton of metal that was stuck to it, right? And so it's a Hall effect sensor. It's got a magnet in the tip, and it was collecting bits of metal from, unfortunately, the inside of this engine. And they said they put a new crank sensor in it, and it fired right up. Now, didn't run great, and actually it was knocking and it sounded really, really bad. They said they're going to recommend an engine only because of the way it sounded, the fact that timing was off. There's metal on the sensor. They're not going to risk doing a timing job on this thing, and I don't blame them. But they did say it started up with a new crank sensor. So I'm not 100% sure if this sensor was inverted, if that's what happened, or if it had more to do with the amount of metal that was on the end of the sensor. And I'm not sure, exactly how that would work. Hall effect sensors are pretty interesting. I've looked at the pull down style before. If you ever get a chance to take a Hall effect sensor, when you have a scope hooked up to it, if it's a pull down style sensor, have the sensor plugged in so it can function, right? It's got its 5 volts ground. Watch the signal wire and take a piece of metal and do this to it. Move the metal across the tip of the sensor in the same fashion. So you're moving it across the tip of the sensor in the same fashion that the tone wheel would move past it, and see what the sensor does. And it should do exactly what it's supposed to. It should pull the voltage down when the metal is present, and then it should go up when the ferrous metal is gone. And then try this. Take the metal piece and move it up and down in relation to the sensor, right? So if you're holding the sensor in your hand pointing up towards the ceiling, move the wrench or the piece of metal closer to the ceiling and then closer to the sensor. So you're moving it in and out as opposed to across the sensor. And what I've seen on some of these Hall effects is it will actually hold that voltage down even after you've moved the metal away when you move the metal in that direction. Now, I can't exactly explain why that is. I think it has to do with how the magnetic fields transition past the sensor. But I'm wondering if the buildup of metal on the end of the sensor had something to do with that. It'd be interesting to experiment with it more. Of course, I wasn't at the shop when they swapped these out, but I found it pretty interesting that it reacted that way, and it prevented the computer from registering an RPM at all. And again, very random spark. I'm not sure on the fuel injection how it decided to feed fuel in there, but it might be a strategy where, okay, I have a pulse, maybe from cam sensors or the crank at all. I'm going to start fueling, but I'm not going to spark until I know exactly where the crank is. I don't know the exact strategy there, but that's what was going on with that one. So those are my 2 case studies for today. Thanks for listening. I really appreciate it. With that all out of the way, let's get out there, start fixing the world one car at a time.